Basic electrical joints and fitting. Part 1. Sector. Plastic processing. Exercise 2.02. Identify, use and maintain wireman's tools.
Dear students, at the end of this exercise, you will be able to identify the tools when specification is given. Identify the tools for specific uses. Apply a film of oil to the tools to avoid rusting. Lubricate the movable parts of the tools for easy handling. Remove the mushroom on cold chisel and hammer. Sharpen the saw teeth and set the teeth for maximum cutting efficiency.
Requirements: tools and instruments. Trainees toolkit, 1 set. Triangular file busted, 150 mm. Long round nose pliers, 200 mm. Flat file busted, 250 mm. Raw jumper and bit number 8. Equipment and machines. Electric bench grinder. Materials: lubricating oil, cotton waste, cotton cloth, emery sheet. Procedure. Task 2. Identifying tools for specific uses. 1. Practice the use of each tool for different operations, as given. 1. Combination pliers. Pipe grip is serrated for gripping cylindrical objects. 2 joint cutters are provided for cutting or shearing of wires. Side cutting edges are provided for cutting of soft wires. 2. Pliers, flat nose. This is used for bending and folding narrow strips of thin sheet metal. 3. Pliers, diagonal cutting. This is used for shearing of wires in confined spaces and cutting of wires close to the surface level. 4. Pliers, round nose. This is used to shape loops in wires and to form curves in light metal strips. 5. Screwdriver. This is used for slot head screws. Use screwdrivers with tips correctly fitting into the screw slot. 6. Screwdriver, Phillips or star. This is used for star-headed screws. 7. Neon tester. This is used for testing live terminals. 8. Electrician's knife. This is used for skinning the insulation. 9. Tri-square. This is used for checking surfaces and squareness. 10. Firmer chisel. This is used for chiseling wood. 11. Tenon saw. This is used for cutting battens. 12. Plumb bob. This is used for drawing vertical lines on walls. 13. Center punch. This is used for making punch marks on metals. 14. Cold chisel. This is used for chipping metals. 15. Hacksaw. This is used to saw metal pieces. And 16. Portable electric drilling machine. This is used for drilling holes in wood or metals. Task 3. Care and maintenance of tools and prevent of rust formation. 1. Inspect all the tools. If rusted, use fine emery paper to remove the rust. While removing rust, keep your hands clear of sharp edges. 2. Apply a thin coat of oil over the surface of the rusted tools. And clean with cotton cloth. A hammer should not have even a trace of oil on its striking surface. 3. Check and lubricate the tools for easy movement of the jaws of pliers. Jaws of wrenches, pincers, and the gears of the hand drilling machine. 4. If the movement is found to be hard or sluggy, apply a drop of oil at the hinged or geared surfaces. 5. Activate the jaws and gears till the muck or grime in the surfaces comes off. 6. Clean the tools with cotton cloth. Remove the mushrooms. 7. Check the cold chisel and hammer striking face for mushrooms. If found, remove the mushroom by grinding. Reshaping the screwdriver tip. 8. Check the tips of the flat-tipped screwdrivers. If the tip is blunt or disfigured, grind it to form the perfect cornered tip for effective usage. Sharpen and set the saw teeth. 9. Check the teeth of the tenon saw. 10. If the saw teeth are blunt, file them to make the saw teeth sharp. Exercise 2.03. Identify the types of electrical instruments.
Dear students, at the end of this exercise, you will be able to identify the type of AC/DC instruments and their functions from the dial markings. Identify the type of AC/DC instruments from the marking on the terminal.
Procedure. Task 1. Identify the types of instruments, AC, DC, and their functions from the dial marking. 1. Identify the instruments shown in figures 1 and 2 for the type DC, AC, or both, and its functions referring to the symbol on the dial with reference to Chart 1. Chart 1. Symbols characterizing electrical measuring instruments. Record your response in Table 1. 2. Identify the function of the instruments in figures 1 and 2 by referring to the symbol on the dial. Record the observation in Table 1. 3. Identify the instruments shown in figures 3 to 8, whether they are single or multi-scale or multi-range instruments, and their functions. Record your response in Table 2. Four. Identify the working position, accuracy or error of indication, type, and function of the instruments in figures 1 and 2, and record in Table 3. Task 2. Identify the type of instrument, AC or DC, from the marking of the terminals. 1. Identify the connecting terminals of the instrument in figures 9 to 11. Note down the mark in the terminals shown in figures 9 to 11. Record your response in Table 4. If the terminals are marked positive and negative, or any one of them is coloured red, the meter normally is a DC meter of MC meter. If there is no terminal marking, then the meter normally is an AC, DC or MI meter. 3. Refer to figures 9, 10 and 11 and identify the type of instrument, their function, and record in Table 4. Exercise 2.04. Identify the types of electrical instruments. Skill Sequence 1. Determine the relationship between voltage, current and resistance in a DC circuit.
Dear students, this lesson will help you to connect the voltmeter in the circuit, read the voltmeter, connect the ammeter in the circuit, read the ammeter, connect the circuit elements in series, test the electrical continuity.
Requirements. Tools and instruments. Ammeter MC 0 to 500 milliamps. Ammeter MC 0 to 1 ampere. Voltmeter MC 0 to 15 volts. Equipment and machines. DC variable power supply 0 to 12 volts 2 amperes. Rheostat 20 ohms 3.7 amperes. Materials. SP switch 6 amperes 250 volts. Resistors 10, 20, 50 ohms 5 watts 1 each. Resistors 20 ohms 2 watts 1. Connecting leads 14 by 0.2 millimeters. PVC insulated copper wires, assorted lengths 8. Procedure. Task 1. Relation between voltage, current and resistance. Voltage variable, resistance constant. 1. Identify the voltmeter from the dial marking V. 2. Identify the ammeter from the dial marking A. 3. Identify the fixed and variable terminal of the rheostat. 4. Connect the circuit elements as shown in Figure 10. 5. Ascertain the value of each major and minor division of the scales. 6. Close the switch, keeping the potentiometer to the minimum value to output. 7. Apply different voltages by varying the rheostat arm of the potential divider in succession across the resistance. 8. Measure the voltage and corresponding current from the instruments. 9. Record the measured values in Table 1. To avoid parallax error, position your eye in line to the pointer and also in front level of the instrument. Position your eye to coincide with the mirror image of the pointer in instruments having anti-parallax mirror. Conclusion. The proved relationship between the current that flows through the resistance and the voltage applied across the resistance shows that the current is directly proportional to the voltage as long as the resistance does not change. Task 2. Relation between current and resistance. Voltage constant, resistance variable. 1. Connect the circuit elements as shown in figure 11 with the 0 to 1 ampere ammeter. 2. Close the switch and measure the current and voltage. 3. Record the values in Table 2. Conclusion. The proved relationship between the current and the resistance value shows that current is inversely proportional to the resistance as long as the voltage does not change. Exercise 2.05. Apply Ohm's law and verify circuit parameters.
Dear students, at the end of this exercise, you will be able to apply Ohm's law to determine current in a simple circuit when voltage and resistance are given. Determine the resistance of an electrical device for specified current flow and applied voltage. Determine the voltage to be applied to a device of known resistance to cause a required current to flow. Calculate the power input to an electrical device given the current drawn and voltage applied. Determine the current flow through a device when the voltage and the power dissipated are given. Determine the power used by the resistor in a circuit of known voltage. Calculate the energy in a simple circuit for a given time. Verify the results with the calculated value.
Procedure. Task 1. Solve the following problems. Problem 1. A 100 watts lamp is connected to 230 volts. Find the resistance of the lamp. Apply the formula power is equal to voltage squared divided by resistance. Resistance is equal to voltage squared divided by power. Voltage is equal to 230 volts and power is equal to 100 watts. Resistance is equal to 230 multiplied by 230 divided by 100, which is equal to 529 ohms. 2. Calculate the current flowing through the lamp from the formula. Power is equal to voltage multiplied by current. Current is equal to power divided by voltage. Power is equal to 100 watts. Voltage is equal to 230 volts. Therefore, current is equal to 100 divided by 230, which is equal to 0.434 amps. 3. Connect the circuit elements as shown in Figure 1. Four. Switch on the DPIC and close the switch S. Note the readings of the ammeter and voltmeter in Table 1. 5. Calculate the resistance of the lamp applying Ohm's law. Resistance is equal to voltage divided by current. 6. Compare the resistance value and current calculated in steps 1 and 2. 7. Repeat the steps 1 to 6 for 230 volt, 60 watt and 40 watt lamps. Exercise 2.06. Measure the resistance using Wheatstone bridge.
Dear student, at the end of this exercise, you will be able to identify the terminals of a Wheatstone bridge. Complete the bridge with resistors. Operate a Wheatstone bridge to get null deflection. Calculate the value of unknown resistance by the Wheatstone bridge measurement. Measure the size of wire using a micrometer. Measure resistance of the wire by the Wheatstone bridge. Compare the resistance of wires of different conducting materials. Determine the specific resistance of various metals.
Requirements: tools and instruments. Meter steel rule. Outside micrometer 0 to 25 millimeters. Equipment and machines. Wheatstone bridge. Materials: resistor 2 ohms 5 watts 1. Resistor 50 ohms 5 watts 1. Resistor 10 ohms 5 watts 1. Resistor 1 kilo ohms 2 watts 1. Resistor 330 kilo ohms 2 watts 1. Battery for Wheatstone bridge as required. Bare copper wire size 30, 32, 34 and 36 SWG, 1 meter in each size. Nichrome wire 20 SWG, 4 meters. Steel, nichrome, aluminium and copper wire 24 SWG, 1 meter each. Procedure: Task 1. Measuring the unknown resistance using the Wheatstone bridge. 1. Identify the ratio arm PQ, variable resistance S, sensitivity control SC, switch S1, S2, galvanometer G, and connecting terminal X, XX of the Wheatstone bridge and correlate it with the schematic diagram of Figure 1. 2. Ascertain the battery condition. 3. Ascertain the values of the ratio arm. 4. Ascertain the minimum and maximum values of the variable resistance. 5. Connect the unknown resistor across terminals X and XX. 6. Set the ratio arm to the approximate value of the unknown resistor. 7. Keep the variable resistor knob in the middle position. 8. Keep the sensitivity control to position low. 9. Close the switch and watch the deflection of the galvanometer. 10. By closing the switch, adjust the variable arm and variable resistance to get a minimum deflection in the galvanometer. This is in case the galvanometer needle overshoots, then you can reset the ratio arm. 11. Increase the sensitivity and repeat step 10. 12. When null deflection in the galvanometer is achieved, note the value of the ratio arm and the position of the variable resistance. Enter the values in Table 1. 13. Apply the formula and calculate the resistance. Unknown resistance in ohms is equal to reading of ratio arm setting multiplied by the value of variable resistance. 14. Enter the values in Table 1. Task 2. Measuring the resistance of different metal wires having the same length and the same area of cross-section. 1. Collect steel, nichrome, aluminium and copper wires of the same gauge. 2. Verify the area of the cross-section by measuring the diameter